Today we're going to go over a brief introduction to Barrick Gold with you, our push for industrial IoT technologies, the Petasense asset reliability and optimization Arun will take care of, along with a pilot at Cortez process, and then we'll wrap it up with how we integrated that into Pi. Barrick Gold is headquartered in Toronto, Canada. 75% of our gold production comes from the Americas. At the start of 2018, we had proven gold reserves of over 60 million ounces. Cortez process is located 100 kilometers southwest of Elko, Nevada, and it's been a mining district since the late 1860s. Cortez has proven reserves of 10 million ounces, which in today's market value, it would be about $10 billion. Yeah, right? Cortez process is trying to harness the potential of predictive maintenance techniques with technology. We're collecting more data to be able to see the machine issues coming sooner. For example, a pump. As an impeller wears, to maintain the minimum flow rate required, the pump speed is generally increased. So if the motor speed is increased to a certain set point to maintain that flow rate, an alarm could trigger an inspection to be performed. Barrick's a longtime user of Pi. We've used it for 10 years, and we've been an enterprise agreement customer since 2015. We have 250,000 tags being tracked, and our primary uses are analytics and visualization, process modeling and monitoring, planning and notifications, but limited use for predictive maintenance. Oops. Until now. Traditional vibration routes were collected every 4 to 5 weeks in a horizontal direction only, and that process took 2 to 3 hours a day to collect that data. Now our samples are taken every 3 hours. With more data, the actual condition of the asset is known and trended for change. So the result was troubleshooting could be done before it resulted in unplanned downtime failures. And now Arun is going to talk to you about the rest of it.
Thanks, Deb, for that introduction to Barrick Gold. My name is Arun Santhabanor, and I'm one of the co-founders of Petasense. Wow, that's a lot of gold you guys have out there. So before I begin introducing Petasense, I thought I'll talk about where we are from a technology journey and what's really driving companies like Barrick Gold to adopt IoT to improve their equipment availability and improve operational efficiency. And some of these trends were really what actually got us started on this journey to build the company. So there are 4 big trends. The first 2, we have to thank the smartphone revolution. Last time I checked, there are about close to 3 billion smartphones. So that's a lot of chips being manufactured at massive scale. So we have, as a result, thanks to the smartphone revolution, pervasive wireless technologies. So I just checked. The cost of today, Wi-Fi and a Bluetooth chip has come down to less than $10. Even a few years back, it was more than double of that, right? So you have this massive scale, billions of chips being made, wireless chips being made by companies like Qualcomm, Broadcom, et cetera. Right? That's one big trend. And the other big revolution is on the sensor side. We have the MEMS sensor revolution, micromechanical sensor. So these are essentially 2D, 3D structures that you've got to a micrometer scale, right? And you're using silicon-based methods to manufacture these sensors and not traditional mechanical methods to manufacture sensors. So again, those are even less expensive than the Wi-Fi chips. And those 2 essential hardware improvements are part of the mega trends. The other two, the audience here and the Pi audience probably doesn't need an introduction to, low-cost cloud infrastructure and advanced data science. The Petium platform was talking about it. Everybody is now talking about how AI is a big trend. I would like to talk a little bit about the cloud computing side too. One of the things that has happened is that even the cost of cloud computing has gone down dramatically. So the cost of, for example, an hour of renting server space on a platform like Amazon or Google or Microsoft, has more than halved in just the last 3 years. In fact, now in the internet, they talk about how Moore's law is being replaced by Bezos's law. That's kind of the scale at which cloud computing costs are coming down. So all of these are what is driving interest in technologies like IoT, for companies like Barrick. So just a little bit about, now I'd like to talk a little bit about Petasense. We are a company based in San Jose, California. We've been in business now for about 5 years. We were founded in 2014. We have about 3 dozen clients. Our clients are in power generation, metals and mining, pharmaceutical, and oil and gas. So traditionally, heavy users of predictive maintenance are turning towards these techniques. And what we have built is an end-to-end system for predictive maintenance. And by end-to-end, what I mean is we make sensors, and these are wireless sensors, and we also make the predictive analytics software. We started off with a focus on rotating machines. By rotating machines, I mean like motors, pumps, gearboxes, fans, compressors. So these are kind of the workhorses in many industries, right? And when these rotating machines fail, they cause unplanned downtime, and this is across industries, whether it's a power plant, whether it's a metals and mining customer, this is a well-known use, right? So we started with a focus on that. Our first, let me show you. So the first product from a hardware perspective we built was this Petasense vibration mote. This is a battery-powered triaxial vibration and temperature device. It has 2 radios, Wi-Fi and Bluetooth. The Wi-Fi is the predominant radio, and you can really stick it on these bearing housings, rotating machines, and it can help monitor vibration. And so vibration is like the heartbeat of rotating machines. So you can predict failures like bearing failures, misalignment, looseness, all kinds of things, right? And then we also built a product called the Petasense transmitter. That's the next product we built. I'll show that to you. Yeah. So this is the Petasense transmitter. It's like an Apple TV-sized device, and it can take any third-party sensors. So if you have a 4 to 20 milliamp sensor, you have a voltage output sensor, it can take this and send the data to the cloud. The idea here is you're going beyond rotating assets. You're going to linear assets like steam traps and valves and electric panels and things like that. Yeah. So that's a little bit about the Petasense system. I'll talk to you about the architecture. So the architecture is really simple. You stick these sensors, or you can also start mount them on these machines. A lot of these machines, as Deb mentioned, they were not really instrumented, and that's kind of where an end-to-end approach works, because you had this guy with a tablet walking around from asset to asset and taking a reading maybe once a month if everything went well, right? So now you have these sensors. You can just retrofit them on all these assets, and all we need is a Wi-Fi network. And in the case of Barrick Gold, they already had a Wi-Fi network, or they augmented the Wi-Fi network to expand it to the plant area. So it works with standard Wi-Fi. But if you do not have a Wi-Fi network, we can help set up a dedicated Wi-Fi network with a cellular backhaul. So from a Pi perspective, this is a very interesting data source, because you're not going through the traditional control systems. You're kind of going over the top and getting the data into Pi. And I'll talk a little bit more about what that means and how they're using it, right? And once the data gets to the cloud, we run vibration analysis software, and also we have a few features that I want to talk about. So it's the same, the features that, from an analytics perspective, that we visualize, right? The web and mobile apps, it is similar functionality to what the guy who went around, collecting all this data, they use FFT to analyze all this vibration data. So it has all those features, except that it's on a modern web interface. So it's on a browser. It's also on a mobile phone. It's on the iOS device. So now you don't have to be kind of, the analyst actually doesn't have to be at the plant. And this has actually helped Barrick Gold to catch many problems when the reliability engineer is logged in and they get an alert and they're able to log in, right? So at a high level, the data goes to the cloud, and then we have mobile and web apps, and those apps have the traditional functionality that was there in the vibration analysis software, FFTs and cursors and things like that, right? But it also has two additional really important features. One, it has a machine learning driven health score. Our approach is slightly different from Petum. It's a very purpose-built machine learning based health score that helps the analyst, where we've built the models, pre-built the models. So all they need to do is collect the data. It's a pre-built model, and it gives a health score. And I'll talk a little bit more about how that works. But the second most important thing is all this data can be integrated with the OSIsoft Pi system. Traditionally, all this data that was collected on vibration routes, they were in an island on their own. So they would just stay there. So process engineers did not have all these insights. So for example, if you had a pump at Barrick Gold, and let's say the slurry was not at the right consistency, and it was because, let's say, there was a problem with the impeller in a pump, you couldn't get that. All you would notice is, oh, something is going wrong with the process. But why is it going wrong? Because this data was in a system that was in a data collector that was it was isolated, and the process engineers didn't have visibility into all of this process, right? So those are the two important features from a Petasense that we provide, the machine learning health score and this integration with Pi, that really helps them to achieve their goals for predictive maintenance and improving operational efficiency. Okay. So yeah, so let me talk about the first feature that's pretty unique. This is the machine learning based health score. So it's a simple score. It's a numerical score that quantifies the health of the machine. Scale of 1 to 10. So it's like a gymnastics score. 10 is perfect, right? Like so 10 is perfect health. And if we see a deterioration, obviously bring the health score down. You can see there it's coming down to 5. So it's obvious, or 0 actually. That's pretty bad. The benefit of a health score is that now a reliability engineer or a vibration analyst on the Barrick Gold staff can become much more efficient, because before they had to collect all this data and pore over each chart to figure out if there is something wrong with the asset. Whether a machine is healthy or not healthy, they had to collect the data, analyze the data. Now with the machine learning health score, they can only review a small fraction of the assets while they know the rest are healthy. Yeah? So it's really a specific use case that they're putting to use. In the future, we also are going to provide some diagnostic recommendations, because what we are essentially doing is, and I'll talk to you about how the health score works. So what we do to determine the health score is, right when we start the program, we input all the key machine specs to configure the pump in the software. And when you configure the machine in the software, you configure all the key parameters that are used to determine the health. And these are the same parameters that an analyst would be using in the traditional world. For example, you get all the bearing details. So you know the key bearing defect frequencies. Those are all part of the machine learning driven health score calculation. So you input all of that, and then you establish a baseline for how the specific asset is behaving in the first 2 to 4 weeks of data collection. So at a default, these sensors, they take a reading once every 3 hours. So in about 2 to 4 weeks, you get several hundred data points of all of these parameters. Because vibration is a real rich waveform, you get a baseline for all of these parameters. One of the things that people in the vibration field may know is that there is no standard good vibration, bad vibration. There are some ISO guidelines, but they're just guidelines. There are so many machines that operate well above the guidelines, and they would be running fine for years together, and they wouldn't have a problem. So when you form a baseline in our software, you form a baseline for that specific machine, and you're looking for essentially deviation from that baseline. You do input some of what are called as acceptable limits, but that's only one factor. So what the algorithm is essentially looking for is deviation, significant deviation from that baseline. And it's not just one overall, it's a lot of parameters. It's about 30, 40 parameters from each measurement. So you form the baseline, and every time a new measurement kicks in, so which is once every 3 hours, it computes a numerical health score, right? So let's say the seed health score you could set as like 9, it's all good. Next time a new reading comes in, it'll recompute. Maybe it's 8.7, maybe it's 8.5. So essentially, you're providing this health score for the analyst, and you can set obviously alarm limits and alarms if it goes below a certain score. Yeah, and we have a booth here in case you want to understand what algorithms we use and how do we make sure that the data is clean, etc. More than happy for you guys to stop by. Okay. So one of the the second important thing we talked about was how all of this data is fed back into the Pi system at Barrick Gold. And in fact, that was one of their selection criteria, because in the past, as I mentioned, a lot of that data was isolated. It was not really integrated. And really, we believe there is a big gap between folks that are looking at the asset world and the folks that are monitoring the process, and they're not sharing information. So by correlating the data that we collect from these assets, these new signals, and by sharing that with Pi, with the Pi system, they're able to get a feel for kind of a holistic health of a process, right? And this is the architecture that we used initially to get started with sending all the tags that we collected to the Pi system. It was a really simple, the Petasense cloud exposes APIs, web APIs, RESTful APIs. So you can get all the data that we collect. And it is really granular, not just overall vibrations. You could go and actually each defect frequency could be a tag, So all of that fine-grained data is available as a web API. And the integration was done in a matter of a couple of days. So we provide a Python scripts that runs on their Pi servers, and that's called the UFL client. So that Python script is extracting all the data from the Petasense cloud. And right now it uses UFL. Some other customers have used the web API. We can use both. You can use the UFL connector, or you can use the Pi web API to get all the data into Pi data archive. So once it gets there, you can use your core site, process book, whatever you may have, whatever version you have, to visualize, add all these tags, into your existing UI, right? So a lot of the process engineers that did not have machine information will now be able to add those those tags to their, to their user interfaces. So this is kind of how they integrated. Now I'll talk about the pilot process itself. Where did they start? What were some of the assets that they monitored, and where are they in the journey? And then hand it back to Deb towards the end. So they started with a scope to just monitor 10 machines, right? So it was tail pumps, Barron pumps. So you can see some of those assets there, pictures of the assets that they have. Obviously, all of this is on the process side. So this is once the ore has been extracted. And so all of these machines are used to kind of convert the ore to the valuable gold, right? Before it becomes worth $10 billion. So these are the assets that make it happen. So they started with about 10 machines. And as I said, the default collection interval is every 3 hours. So now they're getting a lot more data instead of once a month. And even in the pilot itself, we decided, we wanted to do the integration with the Pi system. So you can see how easy it was to install all these sensors. They use two-part epoxy to just stick them on. Some customers may do stud mounting if they are purists, but two-part epoxy works fine. So these are installed on bearings. That's a fan. In fact, within a month of installation, Leonard, who is Deborah's colleague, he's the reliability engineer, he caught a defect within 36 days of getting started. There's a mercury scrubber fan, which is extremely important from an environmental perspective to clean to remove the mercury in the process. So he caught a defect within literally a month of going live. And so you could see that it started showing high vibrations that were increasing. Right now, we just showed the overall in this picture. He also looked at the actual spectrum to analyze what was happening. It was shown as a looseness issue, and they repaired it. They took the machine off. They repaired it. While they were repairing the fan, they also actually found they were inspecting that Oops, sorry, I didn't mean to do that. Yeah. So this frame here, while they were inspecting, this is the fan, but while they were inspecting, they also found that this frame was cracked here. And so they were able to catch that defect. And so that obviously proved the value to them. And so it's been, like a year now, and I would say they've caught more than half a dozen critical defects that could have impacted production. One defect that they just caught, which was a big deal, was on the booster pump. They caught this noise floor. You can see this is like an elevated noise floor, and this is like a classic pattern for cavitation. So this was the other interesting thing was, so they caught the cavitation on this pump, and then what Leonard did was he analyzed, while he was analyzing this pump, he decided to analyze the pumps that were supplying the slurry to this pump, to this booster pump. Because they were like, oh, if something is going wrong here, wonder what's happening on the input side. And so when they did that, they found that, you can see, the picture tells the story. It was just worn out. You can see here, like parts coming off here. Yeah, all gone. And so this was a real picture. So they caught this problem. So this prompted them to ask the question, okay, now we're doing this, what else can we do to improve diagnostics, right? Improve diagnostics. So the first part was, we already talked about this, integrating Petasense into Pi. They were visualizing vibration alongside, vibration alongside the process parameters, and a lot of the process engineers would use this visualization. Right, the site engineers, the process engineers would use it. But then what Leonard wanted to do was sometimes, vibration goes up, but why is it going up? So they also decided to do bidirectional integration. So bring the process data from Petasense into Pi. We just started that project, and this was the first screen. I think they got current. So that is a visualization of current alongside vibration. So it's vibration going up, and is it associated with higher current draw and things like that? So looking is the pump running dry? Is that the reason why vibration levels are going up? So those are the kinds of things they're looking to answer by doing this bidirectional integration. Clearly the users, we cater to both. When we send data to the Pi system, we cater to the existing users of Pi. They may be process engineers, they may be, Deb talked about all those use cases of the engineers. So we are adding value there, and then also getting data from the Pi system. We also want to compute a health score. The health score that I talked about, the 1 to 10 health score, we want to include some of the process parameters in the baseline in the future. That's the direction they're going. So that's kind of where they are. I'll kind of hand it back to Deb to walk through what their plans are.
So today we're monitoring over 70 machines, everything from the mills to the agitators to conveyors to all kinds of pumps. We have 1,200 tags being sent from Petasense to Pi, and we've also started a pilot project at our sister mine, Gold Strike. Some of the benefits we've seen of implementing the IoT system, the Barron pump that we spoke to you about, saved us over $600,000 of potential downtime in just that one instance. We've reduced unplanned downtime and repair costs and improved the overall efficiency of the process. Some of the intangibles, we no longer have emergency failures. I'm sure we will, but we have peace of mind using the Petasense system because we can tell when we're starting to get failures. No more walk-around data collections. unless we get an alarm and we feel like we need more data. And we're standardized approach to asset reliability across multiple sites, which will be very helpful. What's next in Barrick's IoT journey? We're planning on a deeper integration of Pi data into Petasense to leverage the AI-based analytics. We're going to continue deployment of transmitters, collecting additional sensors. The current pilot at Goldstrike, we're hoping that'll expand into production. Our challenge was to connect predictive maintenance technologies with Pi data. The solution, because of the ability to integrate with Pi and the capability of machine learning, our solution was to trial Petasense asset reliability system. The results were successful, and I think I went over some of those. The Barron pump, which was a huge cost savings to us, I think proved that it was a reliable system. And the fact that it easily integrated with OSIsoft Pi was one of the deciding factors too. So our predictive maintenance technicians' time is more efficiently spent now analyzing and troubleshooting issues. So I think that pretty much wraps it up. So if you guys have any questions for Arun and myself, I probably won't be able to answer many, but state your name and your company, and please wait for the microphone if you would.
Any questions? Yeah.
Hi, I'm Tom Wilk from Plant Services Magazine. Thank you very much for your presentation. I had a question for both of you. Under the more qualitative benefits, you listed a standardized approach to maintenance and asset management. Do you see yourself being able to quantify the benefits of more standardized work and standardized approaches to asset management?
I think eventually the consistency of having a consistent system across the entire site would hopefully result in benchmarks being set for how you operate machinery across all of those sites. And that eventually would mean more failures caught actually. It's just that you have to now get it across all the sites and set those benchmarks before you can say there is a standard system. For example, what's an acceptable level of performance of a pump, whether it's at Goldstrike or whether it's at Cortez or whether it's at Turquoise Ridge or any of their other sites. So we need that scale, and I think that standardized system can help do that. And also just when you integrate with process information, eventually if the process engineers are looking again across sites, all of this data can go to them as they optimize their processes. So hopefully the benefits of process optimization will be now more repeatable across all the sites. So there could be eventually some quantity, but I think they need to scale their production across all the sites to be able to leverage those benefits. Yeah.
Thank you. Another question here.
Hi, Jeff Wood with Alcoa. Great presentation, thank you. It looks like you got some great success. In the day of IoT, though, I'm curious why you stuck with like 3-hour manual vibration measurements, is what it looks like, instead of maybe a continuous sensor. Was there some strategy that went into that?
Yeah, so the capability, this is a battery-powered device, so it's a really small battery. They were doing once a month or once a quarter. So this, if you were to do this continuous, you have to replace batteries, batteries a lot, right? So the standard life of the battery is between 2 to 5 years, depending on how aggressively you collect the data. Now, with this device, which is where actually they're going more and more, they're powering this. This can be powered, and you could do more continuous.
Okay, perfect sense, thanks.
Great presentation, Osvaldo Bascour with OSIsoft. I really loved it. My question is for you. What data are you capturing or aggregating in that little device that you are putting into the PI system? Because when you do vibration, you have a lot of data.
Yeah. So we capture the full waveform of vibration. There are two models. There is a model 1 and a model 2. Both of those models, one has higher sampling rates and higher frequency. So it's a full waveform. So closest analogy I can think of is an audio waveform. If we were recording the audio waveform here, all of that is recorded and sent to the cloud. And that's where we do all the FFT computation. Yeah.
Hey, congratulations on the success. My name is Manirul Haq. I'm from Cemex. It's a great device, hardware, so I'm very excited about it. But the question is, we already have some assets where we have, inside the large gearboxes, we have 5 to or 10 vibration sensors already installed, and they are sending me 4 to 20 milliamps. So can your platform use those signals from Pi? Because I have those continuous data. And right now, we probably have found some other ways, but it's interesting, your concept. So can you do it?
Yeah, both ways. You can either, are you getting the full waveform into Pi? Yeah. Okay, if you're getting the full waveform into Pi, yes. Some companies, they just get the overalls into Pi, and so it depends. Then you can use this. In fact, Barrick Gold is using this to connect some of their existing wired accelerometers. Then we don't even make accelerometers. You can connect that and get it, but if you already have it on Pi, you don't even need this. You can just send the data to our software. Yeah.
Oh, good presentation. Michael Wilson from Agnico Eagle. Just curious if you found that the data complements or challenges the OEM maintenance routine, and what's the OEM's perspective on you kind of collecting this maintenance data, and potentially implementing a different maintenance regime around their prescribed one?
So you're saying OEMs may look at this as just to make sure I understand your question, OEMs.
Because a lot of OEMs, they have their own
right.
products they sell that would compete, I guess, with this. And I'm just curious, do they see it as a challenge? Do they endorse this initiative? Things like that.
Yeah, so depends on some of the OEMs. The way we think about it is it would be very hard for a plant like Barrick to have, like, let's say they have different OEMs for, like, if you see their diversity of assets, like how many types do you guys have? Like several dozen. So each one having their own system is probably not, a good idea. So Pi is where the Pi system is where all the process data comes, and if this can feed. So if you have one consistent way to get, we think that's the better approach. Will some of this intelligence get embedded in the future in some of these machines? Maybe, but still the data has to be analyzed and collected in one system. I think.
Do you foresee anything like that?
So some of the OEMs have come up with devices we've seen, at least what we've seen so far are things that get attached to motors or maybe pumps by that pump OEM. And the method there has been more send the data to the smartphone. So they're really not doing continuous data collection yet, because the networking problem of continuously collecting data and sending it is something that they have not yet solved. Because each OEM can only control their distribution is through their through their channel. So we think that may have some benefits for an operator-driven program, like maybe an operator can get an indication. But if you're looking at like a site-wide and insights, how one part of the process is affecting another part, we believe that this is a better approach of getting all of this data into one place. More than happy to continue the discussion of.
There's one more question in here.
Anton Mayo with Barrick Gold.
Thank you.
Great presentation, Deb.
Thank you.
And Arun.
Thanks for your business. Thanks for your business. Appreciate it.
I can just answer some of the questions of the previous question, and then I have a question for you, because I've been in the reliability realm as well at Barrick. A lot of our pumps and motors and things like that are much smaller devices. So they don't have OEM systems. I think what the previous question was regarding OEMs would be the larger mills, things like that, which come with a vibration system, and you're not necessarily going to put this on there. You may put this on there to supplement if you want to integrate with it, if it's a standalone system. So my question for you was, with these, are you only putting them in one axis, or should you be putting them on two axes?
Oh, sorry, I forgot to mention that they are triaxial. So
they're triaxial, so you
yeah.
only need one sensor, and it's triaxial?
Yeah, absolutely, yeah. Sorry, I forgot to mention that. It's a triaxial sensor, yeah. And it also measures temperature, by the way, so the surface temperature, yeah.
Yeah, and some of the other stuff that we're doing with you is now to send the other additional data back to Petasense, like RPMs and
yeah, exactly.
And
I think they're doing pressure current for things that are not connected today.
To the sensor, yeah.
Yeah.
Okay.
Ultrasound is another one.
Right.
I think that you're starting.
Thanks.
Yeah.
Anything else?
Okay,
All right,
thank
we're
you.
good.